Yeah, camps on everyone. Let's start off. Sure, camps on everyone. Why so many people are missing? Great. So last thing that we did was an infinite ladder. Great. Let's go ahead with this infinite things. Let's say there is an infinite grid. So every segment is a capacitor. Every segment has a capacitor C. So here, if you choose 2 points here, A and B, so if you put a battery between these two, and this is going to infinity. This is an infinite grid. So if you put a battery between A and B, then what is the capacitance between A and B? How do we handle this? Others do keep your cams on. How do we handle this? Think for a minute, then I'll show you one model here. If you have an infinite grid, every segment is a capacitor, and the circuit is just going on infinity in all directions. Okay, let me show you one. So listen to this thing. So you can't do this thing. There's nothing series here, nothing parallel here, nothing. So there's only one way to handle this. We use something called principle of superposition. I hope you remember what is principle of superposition. If we have two independent events, so event one creates effect one, and event two creates effect two. If you have event one plus two, you'll get effect one plus two. So what we do here, today's class will be quite important. We have some, like literally every technique that I'm teaching you in this will be exactly same in current also. So this is the idea there. Since the current is going from A and coming from B, let's do only one at a time. Meaning, assume charge is flowing only through A. So assume charge Q flows through A, and this charge rate will go till infinity. So here, technically, you're keeping the battery between A and B, isn't it? So the battery is giving Q to A, and Q is coming back to the battery. That is how the circuit would be. So what I'm suggesting here, let's treat one at a time. So let's assume only charge goes into A. Assume charge Q, enters A, and spreads across the circuit till infinity. So matlab infinity is your second terminal. Means you're keeping the battery between A and infinity till infinity. So which is the second terminal. So A is one terminal and infinity is the second terminal. Now, because the whole circuit is symmetrical, because every capacitor is C, from here we can argue each segment will get Q by 4, Q by 4, Q by 4, and Q by 4. Does everyone agree with this logic? Forget about the battery A and B and everything. Suppose if only A was there, and if you send Q charge through that point A, it will split equally in 4 directions. Agreed? Second thing. Now, remember, in this process, B is here, but B is doing nothing. Second thing. Now, from B, let's say you're pulling out charge Q. Now, this time only you're taking B. So the charge is given from infinity. The charge will come from infinity to point B, and it comes out of B. So here you're keeping the battery between infinity and B. So assume charge Q starts from infinity and comes out of B. So infinity is the positive terminal and the B is the negative terminal. Again, by symmetry, we can say because you're coming out, this should be Q by 4, this would be Q by 4, and this would be Q by 4 and Q by 4. Now, if I do both at the same time, meaning if I send charge through A and if I pull charge from B at the same time, now what does principal superposition say? Look at this segment, okay? Look at this thing which I'm marking in black, the wire between A and B. If you look at the black one, so if I do A and B together at the same time, the grid will look like this. So if you push charge Q through point A, we will get Q by 4 here. If you pull charge Q from here, we get Q by 4 here. Is that making sense? That means whenever you send a charge Q through point A, Q by 4 should pass through that AB line. Whenever you pull charge Q from point B, charge Q by 4 should go through that point line. Means if I do both at the same time, means if I give and if I take, you should get Q by 2 in the middle line. Is that making sense? This is called principle of superposition. Meaning if charge was only flowing through A, in that AB wire, you will get Q by 4. If only charge was coming out of B, you will get Q by 4. If both are doing at the same time, both will give Q by 4, Q by 4. You can see both the directions are same. So if you do both at the same time, you will get Q by 2. Is that logic clear? This is called principle of superposition. And this we have done multiple times. The first time you did this was in projectile motion. Yeah? If you throw a particle at an angle, the vertical component will give you in vertical motion, u sine theta, u cos theta will give motion in the horizontal direction. So whatever happens in x won't affect the y direction, whatever happens in y won't affect the x direction. So both of them will give you a respect to x and y coordinates, and then you bring them back. So far the story is clear. Now, if you solve this, so if you just look at the capacitor A and B, right? So we will get charge of Q by 2 here, Q by 2 and minus Q by 2. So Q by 2 is equal to capacitance into potential difference VA minus VB. But we know C equivalent is what? C equivalent is a charge by potential difference, VA minus VB, which is nothing but 2C. So this entire infinite grid can be replaced with one capacitor of 2C. Are you clear with this definition of capacitance? Isn't that how the capacitance is defined? Charge flowing through the battery, right? How much charge is flowing through the battery? Capital Q. So you kept a battery there and charge Q was flowing through the battery. So here Q is a charge through the battery. So among the total Q, half of the charge was flowing between A and B, remaining Q by 2 is flowing to infinity. That we don't know what is happening. So Q is the charge through battery. The battery is between A and B. So VA minus VB is the potential of the battery. So if you divide Q by potential difference, that should give you capacitance. This is how you handle infinite grids. At least there is no other way to handle them so far. At least I don't know a second technique to handle infinite grids. Is the process clear, everyone? Understood the logic? Because if you send both at the same time, I don't know what to do. But if you send one at a time, because it is infinity, because it is symmetrical, you can make an argument, boss Q by 4 jayega. All got the story? I'll give you one more like this. Now you guys tell me what is the answer. So if you got the logic there, let's say we have infinite hexagons. So an infinite honeycomb goes to infinity, goes to infinity, goes to infinity, goes to infinity in all directions. Each segment is capacitance. I'm not drawing that capacitors, okay, but each segment is C. Let's say this point is A, this point is B, and this point is C. Find CAB, find CAC. Two different questions. Means if you put the battery between A and B, what is the C equivalent? If you put the battery between A and B, what is the C equivalent? Idea is the same. You have to do one at a time. So when they say CAB, it means AB is the ends of the battery. So there, I taught you for a square. I'm asking you for an hexagon. Give it a try. That's it. If you got this, I think no matter what kind of, see one thing, when they give infinite grids, there should be symmetry. If they give some weird, unequal shapes, you can't solve. They can keep triangles now. They can keep polygons. They can do all nonsense. But find the C equivalent between AB and AC. Hmm. Right, somewhere. First part is right. Get the second part also. Right, Srishi. Okay, let me show you. Someone else also got Ishman, right? Utsa. AB, you got it wrong, Ray. I think you mixed up, I guess. Okay, let's see the first one. Again, same story, one at a time. This much is fine. So this is A. So let charge Q go through A. So meaning I'm putting a battery there. So Q will go here. You can see symmetry, Q by 3, Q by 3, and Q by 3 will split. Plus, similarly, this was B there. So from B, if you pull Q, again by symmetry, you get Q by 3, Q by 3, and Q by 3. This was A. Means if I do both at the same time, means you're pushing charge through A. This would give you Q by 3. You're pulling charge from here, and this will give you Q by 3. That means between A and B, this was A, and this was B, and this was C. The charge on this capacitor was 2Q by 3. So 2Q by 3 is equal to capacitance into VA minus VB. But C equivalent is defined as the total charge going through the battery. The total charge to the battery was Q. You're getting it? Battery is giving Q. In that, this one branch itself is taking 2/3 of the charge. Q by VA minus VB, which is 3C by 2. Is that making sense? Easy to solve once you know the process? So you should know how to handle them. Once you know how to handle them, it is easy to solve them. It shouldn't take more than a minute. Can you do for AB, AC? C is here. A, B, C is one branch after. Any doubts on this? Please ask me. It's quite an important model. These are infinite grids. Last time we did an infinite ladder. Today we'll be handling symmetries basically. This is the fourth one. If you remember, first was series parallel, second is Wheatstone bridge, third was nodal analysis, fourth is symmetry. So today mostly we'll do symmetries and maybe a little of nodal analysis if junction lifetime permits. Okay, let's see the next one. Nay, Akanksha, that's not the answer. Trishi, no. How are you guys getting 3C by 4? Look at the next one. So this is A, this is C, this is C. So if you send a charge Q here, we will get Q by 3 here. Again, see this Q by 3 by symmetry, this will be Q by 6 and this will be Q by 6. Agreed, it will split again. You want to go from A to C, right? So first there are three equal branches. So Q by 3, Q by 3, Q by 3. Once the Q by 3 reaches there, both are symmetrical. So it will go Q by 6, Q by 6. Plus, if you do that same logic here, so this was A, this was C. So if you pull charge Q from C, this guy will be Q by 3 and this guy will be Q by 6 and Q by 6. I hope that was making sense. So once you go one more step further, the Q by 3 will again split into two equal pieces because both are equal. Now if you do both of them together, so you're sending from A, so this will be Q by 3, this will be Q by 6. If you're pulling charge from here, C, this will be Q by 3 and this will be Q by 6. So if I just redraw them, this is how it looks. Capacitor, capacitor. This was A. This junction was B. This was C. Capacitance was C and capacitance was C. How much charge is there? Q by 3 plus Q by 6, Q by 2, Q by 2. These are the charges, everyone. This is how it looks. So what is the potential difference here? So you can clearly see the potential difference here, VA minus VC is nothing but Q by C. Basically, this is Q by 2C. VA minus VB. Q by 2 is C into VA minus VB. Q by 2 is C into VB minus VC. Add them, you will get Q is equal to C into VA minus VC. And then you're done, right? That is the definition of C equivalent. C equivalent is Q by VA minus VC, which is C. So this whole circuit is equal to one capacitor C. Are you clear what we did? There are two capacitors in the middle. You cannot directly jump. So first the charge will become 1/3, then it will become 1/6. So the red will give Q by 3, Q by 6. Green will give Q by 3, Q by 6. When you add them, both the capacitors are Q by 2, Q by 2. So the potential difference would be, so that's your equation 1 and equation 2. You want, you can write this thing. This is 1 and this is 2. Add 1 plus 2. You'll get Q is equal to C into V minus VA minus VC. Any doubts on this? I hope you got the process now, right? So tomorrow someone will come and say like this. We have a circuits where all are triangles. They can play like this and they'll say there are infinite triangles like this. They will say this is A and this is B and find VA minus VB. So this is how you handle infinite grids. Any doubts on the process, please ask me. I couldn't find a second way to solve these things other than superposition. And it works only because there is a symmetry. Even if you mess up one capacitor, if you just say this capacitor is 2C and remaining all are C, the circuit is gone. You can't solve. All clear with this? Going ahead. Next one. There. All capacitors are C. Okay. So first thing, when you see a circuit red, ask yourself, is this in series and parallel? Okay, these two are in series. These two are nothing. These two are nothing. These two are nothing. There's nothing else in series and parallel. Okay. Can I use Wheatstone bridge? No. Can I use nodal analysis? No. So gone. Matlab, that is how you keep eliminating. Now, here, if you look at this, there is a symmetry. So let me explain the symmetry. So listen carefully. I call this thing axial symmetry. Axial symmetry or perpendicular symmetry. So let me show you that. Symmetrical circuits. The first thing is perpendicular bisector symmetry. You can call it whatever you want. I call it this way. So how does the symmetry look like? In this symmetry, if you take the two terminals of the battery, now be careful, it need not be always vertical. The symmetrical line will divide the circuit, right, on equal on either side. So each side of the line must be a mirror image. Each side is a mirror image. That is one. The second condition, the terminals A and B are on either side of the symmetrical line. They should be on either side. Terminals A and B or on either side. So if you see a circuit like this, it is a bisector symmetry. So what happens in a bisector symmetry? The first thing that happens if you have a bisector symmetry, because from the left side, right side, see if it is equal, that's if you see all these are equidistant from both the sides, that entire line is equipotential. The bisector line is equipotential. Every point on this will be a midpoint between A and B because the circuit is symmetrical. Is an equipotential is equipotential. Therefore, all nodes on this line will have same potential. I'll show you examples, don't worry. We need to formalize this and then we can see some examples. All nodes on the line have same potential. Therefore, so since you have same potential, any element connected on the bisector can be removed. One. The second thing that happens, nodes along the symmetrical line can be opened up along the line. Nodes along the symmetrical line can be opened up along the line. So it's important how you open them. Let me show you an example. That would make you understand much better. You will actually understand the whole meaning of it. Yeah, okay, he's got the answer. So listen, the example, the one which I gave you right now. Don't look at the length of the wires, just look at the circuit. Like, so this is A, this is B. You can clearly see if I drop a bisector between them, the left and the right are mirror images. Do you guys agree? The left and right, they look identical. They're like mirror images. So this is the bisector. And A and B are on either side of the symmetrical line. Right? Now see what is the argument here. Since because symmetry, if I send a charge Q from here, don't you think Q will come from here? If I send Q from A, Q should come from B. Similarly, if Q1 goes here, by symmetry, Q1 will come from the right side. If Q2 goes here, then Q2 should come from the right side. If Q3 goes here, then Q3 should come from the right side. Everything is a mirror image. Whatever happens on the left, same thing happens on the right in the other direction. Everyone agrees with this picture? Now, in that picture, look at that. What happened? If you look at that Q2, Q3, if I draw the circuit like this, and if I remove this node, See what I did. I removed this junction here. Now, if you look at the picture again, initially Q2 was flowing here, so Q2 will continue to flow. Initially Q3 was flowing here, Q3 will continue to flow. By removing that junction, did you affect the charge flow here? If I remove the junction, did the charge flow here, did it get disturbed? Means whether the junction is there or the junction is not there, the charges don't care. That means I can remove that junction and it's still not going to affect anything in the problem. Is that argument making sense? That means that node can be opened up. This happens only because the left and right are mirror images. Whatever happens on the left, same thing happens on the right. So that means if I can open that node, so this junction here, this node can be opened up. How did you open? You opened it along the line, okay? It should be opened in this vertical direction, along the line. This node can be opened. Why can you open it? Because the charge distribution is unaffected. By opening that node, did you mess up the charge distributions? No, the charges are exactly the same as before. That means it doesn't matter whether the junction is there or not there. Charge distribution is unaffected. But once you remove the node, you can clearly see circuit becomes simply series parallel. These two are in series, these two are in series, these two are in parallel. How much is that? C by 2, C by 2, C. This one, and this one are in series, C by 3, C by 3, and C by 2. The CAB will be 5C by 6. Are you clear with this? If you remove that node, the circuit simply becomes series and parallel. Why can you remove the node? Because there is a symmetry. The charges on the left and the right are identical. So if you remove the node, the charges won't get affected. So it doesn't matter. Any doubts on this? And not only this, I didn't give you this, but let's say if you had a capacitor between these two junctions here, look at this, I'm drawing in black here. If you had a capacitor like that, you can remove that capacitor also. Why? Because this entire red line is equipotential. If you put a capacitor on equipotential surface, there is no potential difference. If that capacitor had been there, you could have removed it. Let me show you one more example. I think that should make things even more clear. Let's say you got a grid like this. Let's say this is A and this is B. And if I say each segment is a capacitor, right? And now if I ask you to solve this circuit, look at this thing. There is a bisector symmetry here. If I drop a line from here, this is your bisector symmetry. The left and right are identical and A and B are on either side. That means all these nodes which you have here can be opened up. These are the nodes which you can open up. So the circuit will look like this, everyone. They can be opened up along the lines. So this is how they're opened up. Did you see what we did? So all those nodes, you can open them in the vertical direction here. Because whatever happens on the left, the same thing happens on the right. Are you clear how to use bisector symmetry? So if you got a bisector symmetry, any node on that line, you can open up. So you look at this node here and look at this thing. You see how it opened up? It opened in the vertical direction. And why can you do that? Whenever you get a doubt, ऐसा क्यों हो रहा है? This is the argument. Whatever happens here and whatever happens on this V shape, the charges are flowing independent of each other. Means whether that node is there or not there, it is not going to affect the problem. Is this clear, everyone? quite an important thing. You will be able to solve a lot of questions later on, but this is the basic idea behind bisector symmetry. Any doubts on this? Anyone not clear, not convinced, confused? Please ask. Don't hesitate. Clear? Sudiksha, Shaurya, Param, Devanshi, Trishi, Samyak, Aditi? Great. The next type of symmetry, axial symmetry. Be careful, huh? Bisector symmetry matlab it will not be always vertical. What if the circuit is in some other weird direction? So in axial symmetry, if the battery A and B are there, the line of symmetry passes through the terminals. So the up and down are identical. Symmetrical line passes through the terminal. So that is the main thing. You should always ask, is the symmetrical line dividing A and B, or is it passing through A and B? If it is passing through A and B, it is axial symmetry. If it is dividing them, it is a bisector symmetry. So each side of the line are identical. And since they're identical and they have same potential difference, which is VA minus VB, they can be overlapped and can be overlapped in parallel. You can just fold the circuit. Let me show you how will that look. Fold the circuit along the line in parallel. So example, let's say we have a circuit like this. And I didn't draw it properly, but length of the wires won't matter anyway, just about capacitance. There, you can see how this whole thing is. In this, actually, if you see, there is both the symmetries. There is an axial symmetry and bisector symmetry. But let's see the first part. So battery is here, A and B. So if you drop a line along A and B, you can see the up and down are identical. So this is your axial symmetry. So what you can do about this line, you can fold it. Did you ever see how they make waffles? If you ever been to a waffle shop and see how they make waffles, they have that machine round thing. They will put that batter here. So they'll put only half batter, half ka thing. And once it is done, they will simply fold this thing about this line, isn't it? When they fold it, it becomes your waffle. You just fold it. Ever seen that? So same thing. So we can just fold the circuit. So axial symmetry. So fold about this line. So when you fold about this line, your circuit will look like this. Now, you have to be careful here. See, when you're folding, look at the things which are changing, okay? This capacitor, I'm putting in red C. These two capacitors will fold on themselves, right? Or maybe if you want, I can put some alphabets also. If I call this point C, this is also C because symmetry. If this is D, this is also D, symmetry. That means this point will become C, this point will become D, this point will be A, and this point will be B. So these two red capacitors, C and C, tell me one thing. If two capacitors are in parallel, what is the resultant capacitance? 2C. So whichever capacitor falls on itself, it will double in capacitance. This guy ka value also become 2C. This guy will become 2C. This guy will become 2C. So when you fold the circuit, all the capacitors which fell on themselves, they become double. But these two capacitors, which are at the middle line, if you see when you fold them, nothing happened. It is still the same capacitor. So this will be C and this will be C. Is this making sense? So when you fold the circuit, if a capacitor falls on one more capacitor, those two are in parallel. Dekho na clearly. If I take this midpoint as some O, this potential difference is OC. This potential difference is OC. So OC, OC, both are in parallel. If two capacitors are in parallel, we get double. Is this making sense, everyone? And once you got this, you can clearly see this is axial symmetry, bisector symmetry. You can open the node and you can solve the circuit. So you can use both the symmetries back to back. Is everyone clear what with this? Understood both the symmetries, axial and bisector? Again, let me revise once. What does a bisector symmetry do? Be careful. Just don't look at the line, okay? Uh, for example, if someone gives you a circuit like this, A is here and B is here, and this is symmetry. What symmetry is this? Axial or bisector? Bisector symmetry, right? It has nothing to do with the line. It need not be perpendicular. A and B are on opposite side. Bisector symmetry. Suppose if you have A like this and B like this, and this is the line. This is axial symmetry. Line passes through A and B. Are you clear? So some people get confused with that word perpendicular bisector. So it should be vertical, not necessary. Axial, horizontal hona chahiye, not necessary. So always see with respect to A and B. I hope you all understood bits and pieces of it. Yeah, it looks confusing. Let's do some problems. That's the best way to get this. So solve this. This will make things more clear. We are drawing a smaller cube, 3 into 3 version. The example I gave was a 4 into 4. So let's say we have a circuit like this. All the segments are capacitors. All these red ones are C capacitance. This is A, this is B. Find CAB. This thing has both axial symmetry, both bisector symmetry. In the example here, I gave 4 into 4 grid. This is more complex. 3 into 3 grid is good. Any answer? Give it a try. Take a minute or two. Get it wrong. That's okay. Give it a try. I want I'll give you more tougher one than this next one, but first let's get this thing. But I'll give you one from resistors. I'm too lazy to draw these big things. You must have noticed drawing is the biggest problem. But take a minute or two. First thing, what to do? Use bisector symmetry. Open the nodes. Then you can fold the circuit. You can do anything first. Think. So most of the time in the exam, right, when they ask you circuits, they generally play with symmetries. They expect you to, think about symmetries and solve. They won't try to give brute force questions generally. राइट हो गया। नहीं सम्यक। नहीं आकांक्षा। You have one answer. Let's see. Should have copied it and I had to draw it again. Let's draw it again. So we got this. Okay. Now, first thing, there is a bisector symmetry. So this is a node. This is a node. So these two nodes can be opened up. This is a axial symmetry. So you can fold the circuit also. So first I will fold the circuit and I will open the node. I'll do both at the same time. Or you want, I can do one at a time. So if I fold the circuit will look like this. So let's fold. I'll do one thing. I'll just put the axial symmetry first. Fold. So when you fold it, the circuit will look like this. Isn't this how it looks? And all these capacitors will become every capacitor will fall on one more capacitor. So all these guys will become 2C, 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 and all are 2C. And this point is also the bisector symmetry. I can open that node. Which direction? Along the line. So be careful. Don't open it left and right. Open it up and down here. So you have to open it along the green line. Open it. Open the node, the green node, along the line. And you need to understand why you're doing that, because left and right current is same. So whatever current is flowing here, same current flows here. Whatever is flowing from down is flowing here. So that vertical thing you can open up. Don't open left and right. Along the line. So now when I redraw it again, this is how the circuit will look like. That node will be opened up. And what are the capacitors? So this is 2C, 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 2C. There. All are 2C. Now you can simplify it further. Look at these four on the top. These four are what? Series parallel. That will be 2C, 2C, C, CC, 2C. All these are 2C by 3. So if you want, I'll just draw it again. So this is how it looks. Beach mein this one, this one, this one, this one. All these four are in series. That would be 2C. That will be 2C by 4. That will be C by 2. This will be 2C. This will be 2C. This will be 2C. This will be 2C. Are you guys able to see the circuit now? Can you see what I did? So these three guys are these three. The four ones are the C by 2. So there I'll draw at the black line. See, look at this black line. So this black line is C by 2. Then you can find the equivalent. कितना आएगा ये? This is 2C by 3. 2C by 3 and C by 2. So 2 by 3 and a half. That is 4 plus 3, 7 by 6. 7 by 6, 2C by 2, C, and that will be another C. So that is 1 by 7 by 6 plus 1. 7C by 13. Check. Right, Samyak. नहीं उत्साह. नहीं Trishi. See where it went wrong? नहीं Shreyansh. Please check the circuit. This is important. Ask me where you got confused. Folding the circuit. Did you double the capacitance? Whenever you fold, capacitor falls on one more capacitor. So you have to double that. Because if two capacitors are in parallel, they'll add up. And then there's a bisector symmetry. That node can be opened up. The green dot can be opened up and down. Once you do that, the circuit looks like this. उसको थोड़ा rearrange करेंगे, so it looks like this. And then it is simply series parallel. Is this clear? It's a pretty good question. Matlab, if you see, we didn't do any big things. It is all about folding, opening, and everything. All got this? Any doubts on this? Let's do one more like this. But this is from resistors. So we have to use resistance ka formula series parallel. Open record. What are you doing? Seriously. Something happened to this stupid thing. Where are you? Hmm. There. If you got this, I think you understood your accident bisector symmetry. But be careful here. Remember the formulas for series and parallel? Resistance in series, R1 plus R2. Resistance in parallel, 1 by R1 plus 1 by R2. So, thoda formulas alag hai. Idea is the same. Nothing changes. The technique is the same. Find the distance between the two terminals. So, these are the two terminals A and B. You can't open it left and right, na re, Trishi. Why the logic hai na? Dekho. Why are you opening it up and down? Look at this. The whatever charge is coming here is going here. Whatever is going here is going here, isn't it? Now, if you open left and right, what will happen? If you open left and right means Q3, Q2, Q3, Q2. Charges equal नहीं हो रहे हैं ना? So by opening it vertically, you're not affecting the flow of charge. So it doesn't matter. So there is a reason why we open it along the line. So remember that way. Blindly, if you remember ना भाई होता exam में confusion आ जाएगा. Oh, why am I opening like this? Why can't I open like this? You open it always along the line because the current flow shouldn't get disturbed. Let's get this. If you got this, you understood axial and bisector symmetry. Just be careful about that series parallel का formulas थोड़ा अलग है. I can't draw this thing with so many capacitors. I'll go mad. So let's do this. Take your time. Take 3 4 minutes. Putting that itself will take a time. But everyone should give it a good try. It's fine if you don't get it or confused. Just give it a try. So how do we do this? So let me draw this. What else? Okay, there is one till the center also. Perfect. Let's copy this down first. Great. And what are the values? R by 2, and then R by 4. So this is R, 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 R. And the second line is all R by 2, R by 2, R by 2, R by 2, R by 2. And the inside ones are R by 4. So I'll just put them in green. I hope it's the same circuit, na? R by 4s and R by 2. Yeah, perfect. Now, first thing, you can clearly see there's an axial symmetry, there's a bisector symmetry. नहीं ना हो गया ऑप्शन तो है ही नहीं ना यहाँ पे there are options here नहीं पा रहा हूँ right Aditi we got it so there we have options there so चलो देखते हैं पहले so first thing what we will do let's fold it axial symmetry so let's fold it about that line ठीक है now when you fold it see what happens to the circuit when you fold it the lower part of the circuit will vanish there. This is how it will become agreed. And what will happen to everything here? Now be careful. When resistors are in parallel, R and R will become what? R by 2. The resistors, when you put them in parallel, it becomes R by 2. So when you fold it, all resistance becomes half. Capacitors will double, resistances will become half. So that is one thing, that bit of a difference. You have to be careful. By chance, if you are doubled it, you will get a wrong answer. Becomes half. Which all things will become half? Be careful now. This guy will become half, R by 2. This guy will become R by 2. This guy will become R by 2. This guy will become R by 4. R by 4, 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 R by 4. And these guys in this thing, these will remain same. This is R by 2. This is R by 4. Because these things, when you fold them, there is nothing is falling on them. Is that clear? The middle line, this line ka capacitors will not change because when you fold them, another capacitor is not falling on this. Any doubts still here? Please ask me before going ahead. This should be clear step by step. All got this? Second thing, we can clearly see there is a bisector symmetry. So that node can be opened up. Which node? This node. Which direction? Along the line. So open the node along the black line. Now if you open that line, let's draw it again. This junction can be opened up. Again, what are the values? R by 2, R by 2, R by 2, R by 4, 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 R by 4. And these guys were R by 2, R by 4, R by 4, and R by 2. Now you can clearly see here, these two are in series. So you can modify this a bit. So this was junction A, this is junction B, this is junction C for just for alphabet. So this is junction D, this is junction E, and this is junction F. So I'll just read out the circuit a little more carefully. So A, we have a resistor to junction C. Then we have one more resistor to junction E. And then we have one more resistor to junction B. Then in the middle, bottom we have one resistor, 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 and resistor like this. This is another junction here. I can put my alphabets G and maybe this is H. This is G, that is nothing, and this is H. Between C and D, there is a resistor. So this is D, and between D and G, there is a resistor. There is a resistor. This is F, and there is a resistor. And between D and F, there is again a bunch of resistors, which is R by 4, R by 4. That is R by 2, R by 2, and R by 4. How much is that? R by 2 into R by 4 by 3R by 4, 4, 4. Wait, those are R by 4 only, no? Oh no, wait, I did a mistake. When you folded them, this became R by 8. This is R by 8 and R by 8. Yeah, this is a big one. You should definitely try this on your own again. So that will be R by 8, R by 8 will be R by 4, R by 4 and R by 4 will be R by 8 again. This would be R by 8. This is this entire branch. Let's put on the values carefully. This guy was R by 2, this guy was R by 2, this guy was R by 2. Between C and D is R by 4, between E and F is R by 4. Between D and G was R by 4. This is also R by 4. This is R by 2, and this is R by 4, R by 4. And this is R by 2. So if I just redraw this circuit, it looks like this. R by 2, R by 2, R by 2. This is R by 2. Why am I getting feeling I goofed up something else? Did I mess up something else here? Mm, yeah, it's also got it. If you're folding, yeah, right, wait, that was a mistake anyway. So this was R by 4, this was R by 4, this was R by 8, this was R by 4. This is again R by 2 and R by 2. ठीक है, all got the circuit? इतना तक clear है? This is right on. So let's see this in the next page. Now, once you got this circuit, you can clearly see there is one more symmetry. If you draw a line exactly through the middle, this is again an axial symmetry. Means again you can fold it. So whenever you fold it again, it becomes half. Now your new circuit looks like. So that R by 2 will become R by 4. And when you fold this, this circuit will become like this. बस इतना ही हो जाएगा. देखो circuit when you fold it, this will become R by 4, this will become R by 4, this will become R by 4. R by 4, R by 4, this will become R by 8. This guy will remain R by 8, and this guy will remain R by 8. Is that making sense? When you fold it, this and this will fall on themselves. These two will fall, and these two will fall. This and this will fold, and this will fold. R by 8 will remain like that only. Now this becomes simply series parallel. These two are in series, 3R by 8. 3R by 8 and R by 4 are in parallel. 3 by 8 into 1 by 4 by 3 by 8 plus 1 by 4. That is multiply 2. This is 8. 8 will cancel. That will be 3 by 20. 3 by 20 plus half. So multiply 10 and 20. 13 by 20. That's your R equivalent. Which one? This thing after first folding, देखो ना, everything becomes half, right? Except the middle ones, everything else becomes half. So I changed the values here. देखो ना, R by 8, I changed it. I think initially I wrote R by 4. That was a mistake. So that is clear, everyone? The first part, when you fold it. Yeah, I think most of you got the answer now. So once you got this, and then the second part is what? The same thing. This same circuit is what I got here. Now I'm saying there is a bisector symmetry, so you can open the node. So this is how it looks after opening the node. After opening the node, look at this thing. This green, the red one is this red one, right? R by 8, R by 8 is R by 4. R by 4, R by 4 is R by 8. So that will be the red one. And look at the junctions here. I marked the alphabets A, B, C, D, E, F, G, H. So A, B, C, D, E, F, G, H. I redraw the circuit. When you redraw the circuit, you will observe there is one more symmetry here. That's again an axial symmetry. Again, fold it. You get this thing. So you have to use 2 times axial symmetry and 1 times bisector symmetry. And that's what I said. If you got this, you understood that axial and bisector symmetries. The final circuit becomes simply series parallel. All clear with this? You should definitely try this on your own. Huh? So you can see the circuit here. Take a rough paper and give it a try. That is how you will learn. Don't look at the solution. After trying 1 or 2 times, you'll get stuck. Then look at the solution. But there, this is a pretty good one. We can do the same thing with capacitors. Instead of R, I can replace everything with C and I can do it. I was just too lazy to draw this. Matlab, such a big thing. So you can see. Question was actually manageable to do. The headache was drawing it every time. Clear with this? This is how symmetrical circuits will look like. And that's what I said. Whatever you learn here, exact same thing you can apply in current. It won't matter much, except the series parallel. Take a break. Come back by 9:45. We'll continue from here. We will do more. Any doubt on this thing, please ask. Okay, come back in 5 minutes. Let's start off. Let's see a few more on this. There, that's one good one. Next seven. Let's see one more. Let's say we got a star like this. This is A, this is B. Again, each segment is a capacitor. So capacitor. There, find CAB. Other scans on. Any answers? These are star circuits. End of this again symmetry. What symmetry is this? That's the first thing you need to figure out. Is it axial symmetry or bisector symmetry? This is the symmetrical line, right? What symmetry is this? Just because it is vertical, don't say bisector. Is the line passing through A and B, or is the line dividing A and B? The line is passing through A and B. This is axial symmetry. Means left and right are identical. So yeah, you can fold it, or you can say potential is same. You can play around. Try, I'll give you a minute more. Someone got an answer. Some have got something. 3C by 5. I don't know the answer. So let's see. Anyone else? Mm-hmm. Samik, in this question, you can play a lot. Huh? You can take these two terminals also. You can put a battery there also and ask you find the C equivalent. You can try that. Suppose the battery is between these 2 points. Anyone else? Why not bisector? Bisector यहाँ पे, yeah, bisector भी है. You can open the nodes. Yeah, you can do it. That also works. You have both the symmetries actually. Okay, let's see. So I will just use the actual symmetry. Look at this argument here. So this is your symmetrical line, right? Meaning left and right have same potential. So look at this point here, everyone. So if I take this point here, I'm marking in red. So if this is C, this also must be C. I'm taking these 2 points here, I'm marking in black. If this is D, this is also D. Do you guys agree with that? The left and the right should have same potential. So if this is C, this is C. If this is D, this is D. Because they're mirror images. Any doubts on that? Now, if they're identical means what? You can remove the capacitor between C and capacitor between D. So capacitors between the potential C can be removed because there is no potential difference. Between node C and node D can be removed. Yeah, you can use bisector symmetry and do that node also. So this is how the star will look like now. Basically, this guy will go off. Look at this line. This line will go off and this line will go off. This is how the circuit will look like. So these two lines will go off. Anyway, now this is easy to solve. Look at this thing. These two are in series. How much is that? C by 2. These two and this thing are in parallel. So C by 2 plus C, 3C by 2. So this full triangle is 3C by 2. Similarly, this full triangle is 3C by 2. This full triangle is 3C by 2. You can fold them also. You can do that also. It works. This triangle is 3C by 2. You have a capacitor here C, we have a capacitor here C, we have a capacitor C, and we have a capacitor C. If I just redraw the circuit, this is how it looks. On the left hand side, you have four circuits, four capacitors. The right hand side, we have four capacitors. And this is how it would look. So the triangle ones will be these ones, which is 3C by 2, 3C by 2. And the blue ones will be C and C and C and C. Check. Are you getting how we draw this? So once you remove these two junctions in the middle, it becomes simply series parallel. How much is this? CC, C by 2 and 3C by 4, half plus 1 by 4, 2, 1 by 4, 3 by 4, 3C by 2 into 3C by 2, C by 2, C by 2. No, wait. C by 2 into 3C by 4 by. So 4 goes off. That will be 3C by 10, 3C by 10, 3C by 10. This will be 3C by 5. Yeah, please check your answers. Right, Arya. Right, Ovia. Yeah, right, Utsa. Are you clear what I did? You can fold it. Same aayega. You can open this node. Same. It doesn't matter. By just removing the two capacitors, your life became easy. Did you understood which capacitors I removed? Right. So these ones I removed between C and D. So if I have to put some dotted line, there I'm putting this black dotted line. I removed those guys. Any doubts on the star? This is a star circuit. Now in this, you can create another type of star also. Remember, there is another star. This is a Christmas star. The previous one is a Diwali star, right? So you can have stars of different types. So you can play around. 9C11, right. Let's see the other shape, cube symmetry. We got a cube here. So this is A, B, C, D, E, F, G, and H. Each segment is a capacitor. So total there are 12 capacitors. Now I can put the battery between any two terminals. So find CAG means you put the battery between G and A, body diagonal. Find CAB, find CAC. Three different questions. Depending on where you keep the battery, you get different capacitances. All capacitors are same. Cube may these are the three things you can get. Any other combination will be these three combinations only. This is called cube symmetry. All capacitors are same. Let's see how will you do this. So axial symmetry, bisector symmetry, infinite grids, infinite ladders, cube symmetry. These are the main things. And then we have something called diagonal symmetry. It's not powerful, but yeah, we will see that later on. 6C near. How did you get that? Think for a minute. I'll show you one. You have to think like this. I am going from A to G. So how many identical paths are there? If two paths are identical, that means their potentials also should be similar. Hmm. 6C by 5. Yeah, that looks right. Param, ne param. Okay, let me help you with one. Listen, we are doing for AG, okay? The logic is pretty straightforward. So you're keeping the battery between A and G. Now ask yourself, when I go from A to G, how many identical paths are there? Now, if you look at the symmetry here, when you want to go from A to G, how many ways can you start from A? You can start from A towards B, or you can go from A to D, or you can go from A to E. Do you agree with this? And observe this. For every path that you take from A to B, you can find a similar path from A to D. You can find a similar path from A to E. Means if you say I'm going A, B, C, G, I will say I'll go A, D, F, G. I'll go A, E, H, G. Can you see? Matlab, if I remove the alphabets, can you tell the difference between B, D, and D? You can't tell, right? They all look pretty identical. Matlab, for every path through B, you'll find a similar path through D and E also. So that's a symmetry there. You cannot tell the difference between B, D, and D when you're starting from A to G. The simple way to see this is when you're going from A to G, look at the number of capacitors you have to jump. So when you want to go from A to G through B, you're going from A to B, B to C, C to G. You jumped three capacitors. You want to go from A to D, A to D, D to F, three capacitors. A to E, H, G, three capacitors. So for every path that you take from B, I can give a similar path through D and D. So for every path from A to G, right, through B, so if you want to go from A to G through B, we can find a similar path. From D and E. So if the paths are identical, that means the potential must be identical. So therefore B, D, E, and E are identical. They have same potential. So if you have three identical paths, the current will flow equally through them. So they will maintain same potential profile. Similarly, you can also argue from the backside. Similarly, C, H, and F are same. And I told you this. If you can eliminate even one node, if you say even one node is identical to another node, means you can decrease the number of nodes. That means we can use nodal analysis. Let's redraw the circuit. So your starting point is A, then your B, D, and E are identical. So you can keep only 1 point for them. C, H, F are identical, keep 1 point for them, and G is the end point. So you're starting from A and going to G. How many capacitors are there? From A to B, one capacitor, one capacitor, one capacitor. There are three capacitors from A, B, A, D, A, E. Then we have two capacitors from B to C and B to H. There are two capacitors from D to F and D to C. And there are two capacitors here. And there are three capacitors here. Total 12 capacitors. You can clearly see these three are in parallel, 3C. These three and 6 in parallel, 6C. These three are in parallel, 3C. All these three are in series. CAG will be 6C by 5. Is the logic clear, everyone? So we used nodal analysis and a cube symmetry. Now you can use two concepts together: nodal analysis, symmetry, infinite degree symmetry. All that stuff will come. Please have a look at this logic. If you got this, please go ahead with AB and AC. Near हो गया. That looks right, Arya. Yeah, first part you're right, Akanksha. Any doubts on A to G, please ask me. Next thing, you want to go from A to B. You use the same logic. When I want to go from A to B, how many paths can I take? In that, how many paths are identical? If two paths are identical, वो सब points का potential same हो जाएगा. मतलब the respective points. That is the whole idea behind this symmetry. Try. Give a try for AB. Out of all the three, AB is the toughest one. But anyone got confused here? Anything you're not convinced here? Please ask. Why is that? Why they're equal? What is that? Anything you're not clear? AB was easy. You felt it easy. Okay, ठीक है then. Well, C by 7. Yeah, that looks right, Samyak. Try, everyone. I'll give you a minute more for the B part and I'll show you for A to B. Do A to B in Hare Akanksha. Why did you do A to C? A to C, I think that looks right. Do A to B. Sudiksha, Arav, adjust your cams. I can't see you guys. Pratyasha, Naisha, Utsa, cams, please adjust your cams. Make sure your faces are visible on the screen. Any other answer? Yeah, let's see A to B. So we are going from A to B. You can ask yourself, when you go from A to B, there are three ways you can go. You can go from A to B directly, or you can go from A to D, D to C, and C to B. So D is one path. Or you can go A, E, H, B. Look at this. A, D, C, B, A, E, H, B. They're identical. Do you guys agree with that? So D and E are same. Similarly, C and H are same. Plus, that's it. F and G are not same. They're different there. So if you look at the paths here, A, D, C, G, and A, E, H, you want to go to B, right? A, D, C, B, and A, E, H, B are identical. So therefore, D and D are same point. So look at this thing. So A, D and D are 1 point. After D and D, you will get F. After F, you're getting G. From G, you're going to H and C. So H and C are one single point again. And then you reached B. So there are actually 6 different nodes. Now redraw the circuit. From A to D, A to E, there are 2 capacitors. I'm just putting a line. You can put a capacitor. D to F and E to F, 2 capacitors. F to G, 1 capacitor. G to H, G to C, 2 capacitors. H to B, C to B, 2 capacitors. कितना हो गया? 9. There are still 3 more capacitors. There is also a capacitor from D to D to H, D to C, and there is also a capacitor from E to H. So there is one capacitor from here, and there is one capacitor from here, and there is also one capacitor from A to B. Look at this. That each line is one capacitor. So if you can just put something like this, it looks like a cute monster also. And there, these are all capacitors. So this is one capacitance, capacitance, capacitance. There, these are 12 capacitors. So if you redraw the cube, this looks like this. So if you do this answer CAB, you get 12C by 7. Please check. Ah, yeah.
So we could have also folded the cube in the plane of ABFG.
A B F A B F G में you'll fold it.
So means each capacitor will get
हाँ वही हो गया
two
ना.
times.
वही हो गया end of the day. You could have done that also. All clear with this? There's still one more left. AC. Right, Samyak. I think AC people did get right, Akanksha. Right, Utsav. AC, I think you got wrong, right, Arya? Try AC. I'll give you another 1 minute. Now the battery is between A and C, the phase diagonals. So don't think like, oh, itna bada kyun hai? Think like this thing. The same thing will come in current. So you're doing two chapters at the same time. So it is worth spending time. And these are actually interesting. Like there is, you just have to visualize things and do it. There's nothing to write equations and, hit your head. This is what they'll expect from you also, that can you visualize the structures and you can make it more simplified. Try. Everyone should try. I'll give you a minute. Some of you did get it. And if you see in this cube, right, if you take any other combination, it will be these three only. There is no other combination you can get in a cube. So yeah, this thing basically covers everything. So when you want to go to A to C, you can see something clearly here. If you go from A to C, can you guys see this? If you draw a plane, this is a bisector symmetry, isn't it? This is a bisector plane. The left and right are exactly mirror images. The plane DBHF is a symmetrical plane. So when you go from A to C, the points B, D, H, F are midpoints. You'll see exactly midpoint. A, B, C, B is the midpoint. A, D, C, D is the midpoint. A, E, F, G, C, F is the midpoint. A, E, H, G, C, H is the midpoint. And it is a midpoint and it is symmetrical on both the sides, meaning uska potential kitna hoga? V by 2. It will be exactly half. B, D, H, F will be midpoints. That means they all have same potential. That means any capacitor between them can be removed. Therefore, all these things will have potential. Potential is same. Therefore, capacitors between B and H and D and F can be removed. Because if you have same potential difference, if they have same potential, there is no potential difference. So there'll be no charge in the particular capacitor. So if you redraw the circuit, now it looks like this. There. This is how the circuit looks, which is pretty easy to solve. So these two are in series, these two are in series, parallel. So this will become C. That is C, this is C. That will become C by 3. C by 3 and C, the CAC will be 4C by 3. Circuit simply becomes series parallel. Once you remove those two branches, the whole thing becomes quite simple to solve. Are you clear with this? This is a bisector symmetry. Why is AG not a bisector symmetry? Because AG is a body diagonal, right? You can't find a bisector symmetry there. See, is A and G a mirror image? If you take a mirror image, you'll not get anything there. So that's a body diagonal. Body diagonal is not symmetrical. Any doubts on this? So cube mate, these are the three variations you have. Any other combination you take will be among these three. So we used nodal analysis and a cube symmetry so that we combine two different things. Any doubts on this? All clear with this? Let's see one more. They're yeah, a little difficult, but once you know, right? Once you did it on your own and once you figured it out, you'll not forget it. It'll be easy to handle second time. When you see for the first time, it is always difficult. Second time will feel like manageable. And what I'm teaching you here, exactly same circuits we will not do in current. There we will do something else. But ideas are same. And so on. You can see this thing is forming an infinite grid. Triangle, 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 triangle. So it's going inside continuously. Triangle inside a triangle. This is A and that is B. Able to visualize that? So this is an infinite triangular grid. All capacitors are C. Find CAB. So the outer triangle, inside you have you join the midpoints with one more triangle, then join that midpoint with one more triangle, and you just keep getting triangles till infinity. So this is like an infinite ladder. So let's see how will you handle this. Okay, let's see a few things here. So first thing, right? We know how to handle infinite ladders, isn't it? We will say the whole thing is X and then we do that. But there is a problem here. If you want to say that, look at this whole thing. If you say this whole thing is X, that is okay. But when you take the whole thing, this is A, this is B, and this point is hanging in air. But if you look at the inside one, this thing is touching here, isn't it? So the whole thing is not same as the inside thing because you're touching there at the bottommost point. Are you clear with that? But we know how to handle that. Look at this. If you observe carefully, this is a bisector symmetry. I know I didn't draw that properly, but that's a bisector symmetry. That means all the nodes on that line can be opened up. So it won't matter. You can remove that nodes actually. Can be opened along the line. Now, if you redraw the circuit, this is how they will look like. Because the node can be opened up, you can just draw it like this. So there, now it is hanging in air, right? And this also will be hanging in air. So, and so on. So all these nodes will open up now. Is that clear? Because of the bisector symmetry, you can open the nodes. And then now you will say, let the whole thing be, let CAB be equal to X. That means you can replace this whole circuit like this. You can replace that whole branch inside with one more capacitor whose value is X. And all these are C. Can you find the equivalent of this? All these are in series parallel. The equivalent of this will be what? That will be again X. So the equivalent capacitor of this C and C will be C by 2, C by 2 and X are in parallel. So that will be C by 2 plus X in parallel. That and these two are in series. So that will be C by 2 into X plus C by 2 by C by 2 plus X plus C by 2. That and this C by 2 is in parallel plus C by 2. This whole thing is equal to X. So you can simplify this C square by 4 plus Cx by 2 plus C plus X plus C by 2 is equal to X. You get a quadratic. So yeah, so I have to solve this. C square by 4 plus Cx by 2 plus C square by 2 plus Cx by 2 is equal to Cx plus X square. Yeah, solve this, you'll get a quadratic equation and you'll get X from there. That's it. Whenever you see something like this, is all an infinite ladder ka problems. Okay, someone got C root 3 by 2, C root 3 by 2. Is it root over 3 by 2 or root 3 by 2? This is right only, right? You got the same. Yeah. Are you clear? So end of the day, this is also an infinite ladder only. Infinite triangle. So once you remove that junction, it becomes the regular stuff. Yeah. All clear with this. So till now, how many different symmetries we saw? Infinite ladder, infinite grid, cube symmetry, axial symmetry, bisector symmetry. These are the 5 things. All clear with this. So whenever you see a question, you should ask yourself, is this series or parallel? Is this Wheatstone bridge? Is this nodal analysis? Is this symmetry? Symmetry means there are again 5. So these are the 4 methods you have to solve circuits. Sometimes you will see nothing will work. Then we have the 5th method, the final one. This will take care of everything. The Kirchhoff's laws. The first thing is Kirchhoff's junction law. The idea is pretty straightforward. It's based on charge conservation. The charge entering a node must be equal to charge leaving the node. That's it. Because charge has to be conserved. Charge entering a node is equal to charge leaving the node. That means if you have a junction, Q1, Q2, and Q3, meaning if you take like this, you can't have all the charge going to a node. That means some of them is negative. So Q1 plus Q2 plus Q3 is 0. The net charge at a node is 0. You cannot have all the charges coming to a node because charge won't be conserved. Somewhere it has to go. So how do we use this? The idea is pretty straightforward. You got C root 7 plus 1. There are 3 people who got C root 3 by 2. But check karo. Look at the idea here. Suppose if you have capacitors like this, C1, C2, and C3. Let's say this voltage is V1, this voltage is X, this voltage is V2, and this voltage is V3. So when you use this junction law, this is what we do. We'll assume let the charge be Q1, let the charge be Q2, let the charge be Q2 and Q3. Since all the 3 charges are entering the node, Q1 plus Q2 plus Q3 is equal to 0. Now listen to this thing. This is the very simple one. We know from capacitor Q is equal to CV. V is the potential difference. So what is Q1? Charge is coming from V1 to X. So we'll assume V1 is greater than X. So capacitance C1 into potential difference V1 minus X. Are you clear how I wrote Q1? Charge in a capacitor is capacitance into potential difference across the capacitor. Charge always flows from higher to lower potential. You drew the arrow from left to right. So we are taking V1 is greater than X. Plus what is Q2? Capacitance C2 into charge across C2, which is V2 minus X. Why V2 minus X? You took the charge from V2 to X. Charge flows from higher to lower potential. C3 into V3 minus X is equal to 0. We will solve this. We'll get X ka value. We get everything from here. Clear? Let me show you an example how to use this. Listen to this example. That's the best way to learn. Let's say someone gives you a circuit like this. Capacitor, 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 and a battery. So this is C, this is 2C, this is C, this is 2V, this is V. Look at the circuit. Is anything in series? Anything in parallel? Wheatstone bridge, nodal analysis, symmetry, kuch bhi nahi hai. The moment you see two batteries, most of the things will go off, nothing will work. And the circuit looks simple, but none of the methods work. Okay? So the question is this, find the charge on the capacitor. Let me show you this question, how to do. So I will teach you with this example. You want to find charges on a capacitor. There are two ways to do this, Kirchhoff's junction law, Kirchhoff's loop law. I'll show you junction law today. Step 1. Choose a point with zero potential. You can choose any point as zero potential because what matters is potential difference. So you can choose any point as zero. It makes your life little easy. Choose a point with zero potential. You can choose any point. So choose a point with conveniently. Step 2. Find the potential of other nodes with variables. So since you took this as zero, you can find the potential of other nodes. If you can't find them, use some symbols. Find the potential of other nodes and name the unknown nodes. So if you don't know the potential, call it X and Y. Step 3, apply the junction law. Great. So let me show you this. So this is the circuit. Step 1, choose any point with zero potential. I will take this thing as 0, 0, 0. Why? This entire thing is the same wire. Agreed? That whole wire is same. So if you take 0, everywhere it is 0. Now, if this is 0, what is the potential at this point? I taught you in a battery. If the negative terminal is 0, then the positive terminal must be 2V. Agreed? If this is 0, then this terminal will be how much? The leftmost terminal, V. Isn't it? If the battery ka negative is 0, the positive terminal is the voltage. What about this guy? I don't know. Meaning there is no battery, there is nothing I don't know. Let this be X. Any doubts on this potential part, please? Everyone ask me. Understood how I got the potentials? You start with 0 anywhere, you'll get this. Great. Let's take this circuit. So this is the potential. Step 2, we got the potentials at the nodes. Take any junction. I'll take this junction here. So let the charges be Q1, Q2, Q3. You can take any direction you want, but this looks convenient, so I'll do this. Now we know from junction law, the total charge entering a node must be 0. All charges cannot go into the node, so Q1 plus Q2 plus Q3 is 0. Great. What is Q1? It is coming from V to X. So it will be capacitance into the potential difference, V minus X. So Q1 is coming from V to X. What is Q2? It is coming from 0 to X. So I'm assuming 0 is greater than X. Signs will take care of it. What is the capacitance? 2C into 0 minus X. What is Q3? It is coming from 2V to X. So that is C into 2V minus X is equal to 0. Anyone confused how I wrote this equation, please ask me. This is the important thing. If you got this, you understood junction law. Charge in a capacitor is capacitance into the potential difference. So Q1 is passing through C. So C into potential difference V minus X. Q2 is passing through 2C. So 2C into potential difference 0 minus X. Why 0 minus X? Look at the arrow. You kept the arrow from 0 to X. So means I'm assuming charge is flowing from 0 to X. So 0 is greater than X, which might be wrong. Science will take care of it. So once I got this, C will cancel. Simplify this. V minus X plus minus 2X plus 2V minus X is equal to 0. X will be 3V by 5. Once I got this, I can find Q1 ka value. Q1 is how much? C into V minus X. 2CV by 5. I got positive. Means my direction is right. Q2.
So 3V by
2C.
4, I guess.
Yeah, 3V by 4. 2V. Yeah, 3V by 4. So this will be CV by 4. I got positive sign. My direction is right. 2C into minus X, 3V by 4. This is minus 3CV by 2. Yeah, my direction is wrong. Q2 is wrong. Q2 is actually going down. Q3 will be C into 2V minus 3CV by 4. 4 to 8 minus 3, 5CV by 4. There, the signs will take care. So what is the final distribution? This is 2V, this is V, C, C, 2C. Look at the charges. This was Q3. This branch may have Q3 coming from here. So from here, we are getting 5CV by 4. This much charge is coming from this battery. So this plate will have 5CV by 4. And then the charge will split here. Q2 is negative, 3C by 2. So this will go 3CV by 2. So this plate will be positive, 3CV by 2. This side charge is coming from this battery, which is CV by 4. So this plate will be positive. I'm only marking the positive plates. This will be CV by 4. Look at this. CV by 4, 5CV by 4, 3CV by 2. When the charge 3CV by 2 will come here, it will again split. 5CV by 4 will go this way, and CV by 4 will go this way. This is the charge distributions. Are the charge distributions clear, everyone? All clear with the steps? Understood how we did this? I'll give you one more like this. You guys give it a try. This is V, this is 2V, this is 3V, this is C, this is C, this is C. Find the charges on the capacitor. Step one, find a point with zero, meaning choose a point with zero potential. You can take any point as zero. Step two, find the potential of the other points or nodes. Step three, assume Q1, Q2, Q3 and apply junction law. You can clearly see there's only one junction, meaning two junctions. Let's get this. Finish off. Last one for the day. Think, take a minute or two, try to figure it out. I'll show you. This, it looks scary with three batteries and three capacitors, but it's actually manageable. Okay, let's see. Someone got it. Yeah, right. Wrong, Param. Samyak, you got it right. Okay, let's see. Take any point with zero. When I see this, I get a strong feeling I'll take this as zero. See, if you can take the negative terminal of a battery zero, it makes your life really easy. Because if the negative terminal is zero, then this point is V, this point is 2V, this point is 3V. Agreed? Straightforward. Let this point be X because there is no battery and there is a capacitor. Let the charge be Q1, let the charge be Q2, let the charge be Q3. There, Q1, Q2, Q3 are the charges on the capacitor. Q1 plus Q2 plus Q3 is equal to 0. So what is Q1? Capacitance C into potential difference V minus X. So what is Q2? C into 2V minus X. 3C, that is also C into 3V minus X is 0. C gets cancelled. We get X is equal to 2V. Yep, and you're done. So what is Q1? Q1 will be minus CV. So my direction is wrong. Charge is actually going that way. Q2 is 0. The center capacitor has no charge. Q3 will be CV. You're done. So the final answer distribution will look like this. So this 3V battery is actually giving charge CV. This is the positive plate. The CV comes here to this junction and all the CV will go here. There will be no charge here, 0, 0. This will become CV and the charge CV will go here. CV will come here and CV will come back to the battery. So the CV is just flowing on the outermost the circuit. It's not entering the middle branch. Is this clear, everyone? Understood how to use nodal analysis? This is a junction law, I mean. Next class, when we catch up, we'll continue from here. We will see more of the circuits. I will give you 2 to 3 more, junction logger circuits. Once we get used to this, then we will go ahead. The next class also will be quite an important thing. We will be doing what happens if you attach one capacitor to another capacitor and all that stuff. So I think mostly we should be able to wrap up this chapter in another 2 classes. But the last class would be mostly on dielectrics and all. That's all fine. We have done almost 21 questions and today's class is really important. So please make sure to spend some time revising the whole thing, right? Read all resolve the circuits on your own and then have a look at it. With that, we'll wrap up for the day. I'll see you guys again on Thursday. We'll continue from here. So any doubts, anything else, please stay back and ask. Also free to leave.